Okay guys, in this video what I'm going to show you how to do is how to calculate a compound conditional. So let's take a look. Let's tell you I said A equals 1, 1, 0, 1 and B equals 0, 1, 0, 1. And what I'd like you to do is I'd like you to calculate not A or B. So let's do this. Step one is not A means invert each A bit. So not A, so that means A becomes 0, 0, 1, 0. Or, we're going to write or, B stays what it is, 1, 0, 1, 0, 1. So let's go ahead and line these up to or them. 0, 0, 1, 0, 0, 1, 0, 1, and we'll put or. So 1 or 0 is 1. 1 or 0 is 1, 1 or 0 is 1, 0, 0 is 0. So the result of not A or B equals 0, 1, 1, 1, given that A is 1, 1, 0, 1 and B is 0, 1, 0, 1. Let's do one more example. We're going to keep A and B the same. All right? So let's say we want to figure out A and B or not A. So let's go ahead and break this down step by step. Let's calculate A and B. So we're going to say A is 1, 1, 0, 1. B is 0, 1, 0, 1. And let's do A and B. 1 and 1 is 1. 0, 0, 0, 1 and 1 is 1, 1 and 0 is 0. So this becomes A and B right here. So I could just replace this with that. And not A becomes 0, 0, 1, 0. All right, so this right here becomes that. So let's or them. Let's or them. So we get 0, 1, 0, 1, or 0, 0, 1, 0. And 1 or 0 is 1, 0 or 1 is 1, 1 or 0 is 1, 0 or 0 is 0. There we go, and that is my answer. So my answer to this problem is right there. So A and B or not A is 0, 1, 1, 1. Now, you probably don't see a use for this because we're not designing a chip. And we're not going to be designing a chip in this class. But just know that the implications of this allows you to do stuff like Karnaugh maps and things of that nature to design multiplexers and half adders and full adders and all the things that are necessary to construct a CPU. So again, thank you for watching.